Here we go. A way to regroup rational functions. Oops. Rational functions when the numerator power is greater than or equal to the denominator power. We got this. We're going to break this up into x over x plus 1 over x. So really, we're just doing 1 plus 1 over x dx. So we've got x plus x plus c. Whole different story. If your binomial is in the denominator, we're kind of stuck. It should be simple, but it's not that simple. But here's what we can do. We can add 1 and subtract 1. Because x plus 1 minus 1 is still x. So now we're here, and here's why I call it the regrouping trick. We're going to regroup it into x plus 1 over x plus 1 minus 1 over x plus 1. So now what we're really doing is 1 minus, so we've got x minus ln x plus 1. Pretty easy trick. Let's try another one. Well, if the numerator power is larger, this trick can also work. So what we need to notice is that if we can make this quadratic have a factor of x plus 1, that'll work. Well, the easiest way is to think about the difference of two squares. What if this thing were x squared minus 1? Then it would factor as x plus 1, x minus 1. Oh, we can do that. Let's subtract 4 and add 4 to the numerator. So now, when we regroup it, this is x squared minus 1. So our integral turns into x plus 1 So we can do the same thing if we have a quadratic where it's bx. So here we want to pull the same trick, and so we really don't want to mess around with this. It's actually possible, but it's not the best habit. So we really want to just mess around with our content. So what if we had x squared minus 2x plus some value c, and we wanted one of the factors to be x plus 1? Well, the easiest way to make this work is what if we had a factor of x minus 3? Well, then we'd have x squared minus 2x minus 3. Oh, that's a plus 1, so we need to subtract 4, add 4. So when we do that, now if we regroup, so we're here, so we can say x plus 1, x minus 3. Easy trick. So they can, next week we'll look at when the denominator has a larger power than the numerator.